Hey everybody, this is Mr. Aynesworth, and we're going to get into another mind map here, but this time it's going to be on solving trig equations of the type y equals a sine of bx, and I may even throw one in there with a cosine of bx, where the period is affected. All right, we're going to start simple, and we're going to see how these have more than one solution. In fact, some of these, when you compress the period or compress a function, and when you change the period, you have more than two solutions. Okay, so let's take a look at this here and let's get started. Let's take a look at an easy one here, and let's solve here. Let's go into the upper left here. Let's solve 2 sine of x right here, minus 1 equals 0, okay, on the interval from 0 to 2 pi. So we limit the solutions there, okay? Because the trig equations have an infinite number of solutions, guys. So you have to restrict the domain here so that you can limit the solutions. Unless you want to write in general form, you could do that too as well. All right, but I'm going to limit the solution so we can see how compressing or stretching out the period, changing the b value, as you guys know, changing what you multiply the angle by, all right, affects the number of solutions. And so we're going to do a little mind map on this and go through the different cases, because on your exam, guess what? You're going to have a simple one like this, and you're going to have one that's compressed, and you're going to have more than two solutions. So you got to practice the right way, and you have to know how to adjust and use the period to get multiple solutions. All right, so here we go. I'm going to isolate the function here by adding 1. So we have 2 sine of x is equal to 1, divide by 2. All right, you get sine of x is equal to 1/2 right here. And now you need to take the inverse sine. So as you guys know, to find the angle, and again, x is an angle, you take the inverse sine of 1/2. And then you think, special right triangles or the unit circle here. So I'm just going to draw the 30, 60, 90 here. So you have it in your sights. So you put your angles in. You got a right triangle here, and it goes 2, 1, rad 3. And we know that the sine of 30 degrees or pi 6, sine of pi 6 or 30 degrees, we know that's equal to 1/2 because we know SOHCAHTOA. Okay, SOHCAHTOA. Okay, the sine is the opposite side of the angle, which is 1 divided by the hypotenuse. Okay, so going back to basics right there. So the inverse sine is restricted from negative pi halves to pi halves, so we get a solution there. But we know that sine is positive in 2 quadrants, okay, quadrants 1 and 2. So we actually have 2 solutions, okay, quadrant 1, all right, and quadrant 2. So here in quadrant 1, our first reference angle here is pi 6, as I said, or 30 degrees. Let's stay in radians here. So radians. If I said 0 to 360, then I'd say, okay, that would imply that you're in degrees, but we're in radians. So express your answer in radians. And then to get from quadrant 1 to 2, you got to take your angle and subtract it from pi. Okay, so the method here is pi minus your reference angle, which is 5 pi 6. And if you look on the unit circle, the sine of 5 pi 6 is still 1/2. It has the same value. Okay, so we have 2 solutions here, all right, pi 6 and 5 pi 6. That happens when you're just dealing with the parent function sine x. And remember, this is just a sine function here cut by a horizontal line at 1/2, and the horizontal line at 1/2 just hits the sine function at 2 different points at pi 6 and 5 pi 6. In fact, you know what? That reminds me, let's just do a little check. When you're doing this on your own, as you guys know, we do this a lot in class here as I demonstrated. The Desmos here is your best friend when it comes to checking. And so all you have to do is type it in. So let's type it in. So y equals sine x. Very simple. Well, you got to type it in correctly here. Okay, so y equals, you got to hit the equal sign. Okay, you type in y equals sine x, the function there. And we'll have to adjust the axes here in a minute. You want to see where it's equal to 1/2. So you enter another function called 1/2. Y equals 1/2. Very simple. Come on. My key is not responding here. Okay, now you can't really see the solutions here, so click on the wrench and let's go from 0 to pi. So we adjust the x-axis from 0 to 2 pi. Okay, I've done this in class with you guys too. And let's put a step at pi halves. So put your step at pi divided by 2. And then you go back here. And then you can see that this function intersects the graph at pi 6 and 5 pi 6. Look at that. So you can check your work. easily with Desmos here. You just click on the solutions. Just know how to use it. All right. So first one there, we have two solutions, pi 6 and 5 pi 6. Now let's see what happens when you change the period. So let's compress it. So now let's solve, let's say 2 times sine x. Oh, no, excuse me. Let's change that. Let's change it to 2x now. Instead of x, it's now 2x. All right, minus 1 is equal to 0. So now isolate your function by adding 1. So 2 times the sine of 2x here, all right, equals 1, divide by 2. Same thing as we did before, but now it's the sine of 2x equals 1/2. And here, when you take the inverse sine, you have not x, but 2x is equal to the inverse sine of 1/2. So on this one here, yes, you're going to get the same, you're going to get the same two initial solutions, but they're not actual solutions. They're solutions for 2x, not x, all right? So 2x is going to be equal to your first solution, pi 6. That's in quadrant 1. And your other solution, as we know, it's 5 pi 6. So let me just emphasize something. This is quadrant 1, and this is quadrant 2, okay? Now, these are solutions if the period was not compressed. But when you compress the period, this function here oscillates twice as fast, as you're going to see here when we check our work, and we're going to have twice as many solutions. All right, so these are not the actual solutions. We got to divide here by 2 and solve for x. Okay, when I say divide by 2, it's the same thing as multiplying by a half. All right, because you take a half of a 6, you get a 12th. And so now our real answers actually are pi 12ths and 5 pi 12ths plus multiples of the period. Now, let me go back. I should have put in the period here. So plus 2k pi, where k is an integer here, right? You divide that by 2 as well. So we're going to add the k pi, which is multiples of the period. Let me just emphasize something here. B is 2 in this case. Okay, and as you guys know, if b is 2, the period is always 2 pi divided by b, which is 2 pi divided by 2. And so you guys know that the period here is pi, and that's why we are adding what's called multiples of the period. And that's how you get two more answers, okay? So what we want to do is add pi to this solution, and we want to add pi to this solution, and we're going to get the third and fourth solution. So really what we have is pi plus pi 12ths. And as you guys know, when you add, you're dealing with fractions here. So pi is really 12 12ths pi, right? So when you add pi to pi 12ths, you actually get 13 12ths pi. And you add pi to 5 12ths pi, you add 12 and 5 is 17, so you get 17 12ths pi. So we actually have 4 solutions here, okay? And so let me just make sure you follow me here. So the first two are pi 12ths and 5 pi 12ths, and then 13 pi 12ths, and then 17 pi 12ths. And if you add a pi to either one of these right here, you'll be beyond 2 pi. All right, so we're going to stop at this point. We have 4 solutions. So if you compress the period and change b to 2, you have twice as many solutions. Let's see what happens when you change it to 3. Oh my goodness, what happens? So let's just play with the idea. Again, this is a mind map, right? We're brainstorming all the different things. And so actually, before we do that, let's go to Desmos here and let's just check our answers, right? Because you want to do that when you're at home, when you're practicing. Because practice doesn't make perfect, people. Okay? Perfect practice makes perfect. And you got to make sure. So now what you do is you just change the function from sine of x to sine of 2x. And notice that it oscillates twice as much from 0 to 2 pi. So here are the first two solutions here. Pi 12ths and 5 pi 12ths. Click on the next one, 13 pi 12ths. Click on the next one, 17 12ths. Okay, pi. So there we go. We got 4 solutions right there. Very easy to check. All right. So now, what do we have? We're doing a mind map, right? We're gonna explore all the different cases here and get good at it because you don't know what's going to happen on the exam, right? You don't know what kind of compression or stretch they're going to give you, but I can tell you guys that I'm going to give you a little bit of everything. So you're going to have to solve the basic one like the first one here, and you're going to have to do a variation where the period is changed and it's either compressed or stretched. I do know that. I can tell you that. Okay, so now let's do another one here. Let's solve sine of 3x here is equal to a half. I'm just going to solve for the function initially because I don't need to go through that. And then again, we're going to solve from 0 to 2 pi again so we can restrict the number of solutions. And then we'll go from there. So let's zoom in here and take a look at this. Okay, so once again, you take the inverse sine as you always do. So here, now 3x is going to be equal to the inverse sine of 1/2. And we know the initial first two solutions. So go back to the very beginning here. It's going to be 5 pi 6 and also 5 pi 6. Okay, that doesn't change. But it's equal to 3x, not x. Okay? All right, b here is obviously 3, and this has been compressed. So it's going to oscillate 3 times between 0 and 2 pi, as opposed to only once. It's going to go up, down, cycle 3 times from 0 to 2 pi, which means we're going to triple the number of solutions. So I'm expecting 6 solutions here. So I have 3x is equal to, again, the first two solutions from the apparent function, okay, pi 6 and 5 pi 6, plus multiples of the period, 2k pi, where k is an integer here. So k is an integer. And then, you could divide everything by 3, okay, or, so I could say divide by 3, or I can just multiply by a third. And it might be easier to multiply by a third here because you're dealing with fractions, right? A third times the 6 is an 18th. Okay, so now here our solution actually is pi 18ths and 5 pi 18ths. Plus, here we got to be careful, we divide it by 3, so we take 2k pi, divide that by 3, and we know that that 2/3 pi there is the period, okay? So again, this portion, what this means right here, we're adding multiples, okay, of the new period, which is 2/3 pi, okay? If b is 3, that tells you that the period is 2/3 pi, and that's how you get multiple solutions. So here we go. We're going to have to add 2/3 pi to each one of these, but we're dealing with 18ths. So let me make a little note here. So 2 pi thirds. If I multiply this by 6/6, I get 12 pi 18ths. So really what we do is we add 12 to the numerators. Okay, so I have to add the period, 12 18ths pi. Okay, so plus 12 pi 18ths to this one and this one. Okay, we got to do it to both, right? And then what do we get? Well, I get more solutions. I get 12 and 1 is 13, so we get 13 pi 18ths here. 5 and 12 is 17, so I get 17 pi 18ths. But then again, I got to add again another period, right? And I keep on doing that until I'm out of the domain of 0 to 2 pi. So I do it again. So let's see, what do I get? So 12 and 13 is 25, so 25 pi 18ths. Again, I'm adding the period right here, and the period, as I said earlier, is 12 pi 18ths. And again, I add it here, so 12 pi 18ths. Do this in your head. Just add 12 to the numerator, all right? And 12 and 17 is 29. So I get 29 pi 18ths. So I get 6 solutions here. Look at this, 6 solutions. Here they are. All right, so let me just write them out in detail. My first two are pi 18ths and 5 pi 18ths. Next two, 13 pi 18ths and 17 pi 18ths. And then the last two, 25 pi 18ths, and the last one, 29 pi 18ths. I get 2, 4, 6 solutions in all. Now, that was a lot, right? So let's do ourselves a favor here. Let's bring in Desmos and let's check this. All right, which is what I do all the time with you guys. All right, so let me find my original file. We changed 2 to 3. Look how easy this is to check. All right, I'm going to go, let me see, I should go full screen on this so you can see things better. Okay, so here are the solutions here. You just click on the values where the horizontal line meets the wave. Are the intersection points, and those are the solutions. So I can't screenshot this and bring it in because I'm recording the screen right here, but you should. Okay, screenshot this, bring it into your lesson, and then you can verify everything that I just said. Okay. All right, and so there's the third one there, and then the last one here. Let's, instead of compressing it, let's stretch it. All right, so let's change b to a fraction less than 1, like 1/4 or so. All right, so let's go down here. Let's do a stretch. Because you don't know what I'm going to give you on a test, right? So let's solve um, sine of 1/4 x equals 1/2, and let's see what happens. So let's zoom in here. So now what's going on? So now, okay, so look, b is 1/4, right? So if b is a fourth, that tells you that p is 2 pi divided by b. So my new period is 2 pi divided by 1/4, which means that the period is 8 pi. Holy cow. Okay, that is a stretch, my man. Okay. Oh, I didn't mean to say that. Okay, so we take the inverse sine. So here we go. This doesn't change this step. You take the inverse sine of 1/2. And guess what? You get, oops, sorry. You get the same two solutions as we always get. Look again. In every single one of these, you start off with pi 6 and 5 pi 6 because we're dealing with the same value, right? We're taking the inverse sine of 1/2. So that doesn't change, but it's equal to 1/4 x now, which is completely different. So our initial solutions that we start off with, which is pi 6 and 5 pi 6. Again, this is a quadrant 1 and quadrant 2 initial solution. But these are solutions for x, not 1/4 x. So we have to multiply, all right? To solve for x, we got to multiply by 4 and then simplify it. So here we've got 4 times, got to multiply everything by 4. So we got to multiply this by 4, 4 times 4, 4 6 2/3, all right? So x is equal to 2 pi thirds. And this one here, 4 times, let me see, let's simplify. 4 6 is 2/3, 2 times 5 pi is 10 pi, so 10 pi thirds. Okay, so 10 pi thirds. And then, plus, well, initially it was 2k pi, but now it's 2k pi divided by 4, or excuse me, times 4. Times 4, 2 times 4 is usually 8. So that's 8 pi, there's your new period. Okay, so 8k pi. That is your new period. And if you want to get more solutions, an infinite number, you just keep on adding 8 pi because we're talking multiples of the period, as I keep on saying. All right. Now we're looking for solutions, okay, from 0 to 2 pi in all of these examples. Which one of these solutions is beyond 2 pi? Well, obviously 2/3 pi is between 0 and 2 pi, but how about 10/3 pi? So 10/3, okay, you got to be thinking that's 3 1/3. So 10 pi thirds is 3 1/3 pi, and guess what? That is greater than 2 pi. So this is out of the domain, okay? Out of the domain. Okay, and the domain, as I said earlier, we have to solve for solutions from 0 to 2 pi. So here we only have one solution. And that is x equals 2/3 pi. Okay, there we go. So if you stretch it long enough, okay, then guess what? You may only have one solution, okay? If you compress it, as you've seen in 3 examples here, or 2 examples, we only had 2 compressions here, you can have 4 solutions if B is 2, and if B is 3, you can have 6 solutions. If B was 4, you'll have 8 solutions. We've done that before, right? But if B is a fraction and you stretch it out, you may only have one solution. There you go. Now on the exam, again, you got to practice in such a way that you're ready for anything, right? And on the exam, I can tell you that there's going to be something basic like the first one in the upper left. And then there's going to probably be a compression where you're going to have multiple solutions. So practice well, study well, and then of course, back everything up with Desmos. Oh, speaking of that, we didn't check the last one, so let's check it. Okay. So here we go. Let's go back to our original file and let's change 3 to 1/4. Watch what happens. Okay. So from 0 to 2 pi, we only have one solution, and there it is, 2/3 pi. So simple to check with the new technology right here. All right, so do yourself a favor, make yourself proud, do your mind maps of all the different concepts here in our AP Pre-Calc class, and then I will hopefully see you in class here or in another video, one of the two. You guys take care. Bye-bye.